Hello, everybody. How are you all? I hope you all are fine and safe. Okay, so let me introduce myself. Well, I am Aman Gupta and I'm from India, a student of Standard 12 and obsessed with mathematics and astrophysics, right? So now what we are like today, what we are going to deal with. Well, usually I just bring up mathematical questions and more specifically it's about integrals, but now we are going to talk about our, yeah, this is what we are going to do, our universe, and we are going to dive deeper in it as much as we can. Well, you know what, when we talk about our universe, it sounds like we are talking about everything, right? Well, it's not well, if I'm talking more like specifically or more clearly, it's our obviously observable universe, right? That's of we are going to talk of, right? And now what, like, I think we should begin. Well, I'm just going to give you some basic knowledge about our universe. Okay, uh, before everything, let's like before not before, let's begin with everything else. Now, let's talk about our universe, like how does it looks like. For our preference, we are going to draw our universe as a giant circle, and this is our observable, as I mentioned over there, observable universe. Well, why we say that it's observable? Because we don't know about how big this is. This could be far more beyond the imagination of human being. So that's why. Okay, let's say that this is the center of our universe. So this, like this length, imagine how big this is. According to a Google data, it's around 93 billion light years. And well, let me make it clear first that I'm going to deal with the information based on Google. So please bear with me. I have not calculated all these datas by myself, but I'm taking these datas as a perspective to make you understand how big this universe is, or how something big or how small that is, right? So not well, Google is not accurate too, but we just take it as a perspective that yeah, it's close to that, like it's close to the real value, so that's why. So Google says that it's around 93 billion light years, and that, well, oh, wait a second, yeah, when we talk about this thing, 93 billion. So you guys are familiar with this number. This is not that much big to determine the diameter. Like this is the diameter, right? Uh, this is the diameter of our observable universe. So it's not that much big number determining it, but what is added in it determines this. And this is what the real beast is, a light year. Okay, so let me tell you what is a light year. So light year is a distance, is a distance. Well, it's a constant, and I will tell you the value of this. That covered, that light covers in a year, right? And I hope you all know about this. I hope you have a like. you have information about this, that the speed of light is 3 into 10 raised to the power 8 meter per second, right? And this is a very big number. Like, if you're taking it as, like, if you're going to understand it as our day-to-day perspective, then just imagine that this is Earth, okay? This is Earth and this is Moon, and the distance between these two is approx 3, yeah, it's something like that, 3,84,000 kilometers, right? And if, like, no, yeah. So, and if we are going to travel with the speed of light between this, like this distance, if you are going to travel this distance with the speed of light, you would be reaching the moon in just 1 point something second. It's not that, like, it's not in 1 second, because if like, if you convert this data into kilometer per hour, then you will get that it's around 3 lakh kmph, right? Kmph. So, like, you would have like, you would need more than 1 second to reach the moon, if you're going to travel this with the speed of light. So you can imagine that this is that much faster, right? And well, I just made you understand about those facts, and that's the speed of light. And when we just look at a year, so we all know that it's just 365 days, or 365 times 12 uh, months. No, sorry, sorry. Wait a second. 365 times 24 is hours, because 365 days, and we have 24 hours in one day. So if you multiply these two quantities, then you would have a hours in a year, right? And if you multiply 365 into 24 into 60, you would have minutes. And more precisely, 365 into 24 into 60 into 60, you would have seconds. So yeah, this is very big number. And when you calculate the, like, when you divide the speed of light with this quantity, you would have that the light covers, well, the light covers is light year. The light covers that much amount of distance, 9.46 trillion kms. So you can think about that, how big this number is. So you need to keep remember that one light year is equal to 9.46 trillion kilometers, right? So a light travels 9.46 trillion kilometers in a year. Just rewind your 1 year from now. So light must have covered 9.46 trillion kilometers. So you can imagine that this is very fast. And that's why light is the fastest, like, what do you call, fastest unit, or you can say the fastest physical quantity that existed. And well, I'll tell you in a moment that the universe is expanding. And you know what, the the speed of expansion of universe is more than the speed of expansion of universe is more than the speed of light. But it's a theory, not proven, right? Let's move on to the next page. So you saw that what is light is, the diameter of universe. And when, if you want to just calculate like this quantity, let me change the color. Let's yeah. So if you want to check this quantity out, yeah, if you want to check this quantity out, then multiply 93 times a billion, that is, I think, 10 to the power 6 or something. I don't know about that, but yeah, you know that. You could check this out on YouTube or Google, sorry. And billion times 9.46 trillion. So yeah, this is very big. Like what do you call it? Big, like huge. So you can think of how huge our universe is. And next, what we are going to study, like what next, what we are going to talk about is, okay, let's talk about something different. Like, look, we have talked about the universe. What happened to it? We have talked about the universe, right? But universe is made up of a million, billion, maybe billions of galaxies. Well, if I'm going to make a chart of universe, like, then just look at this. Um, Small planets, no, small asteroids, meteoroids, uh, asteroids, meteoroids, or something else, small planets. Well, this is going to be bigger and bigger, and we are going to reach with the universe like in ending, bigger and bigger. And we can put like a big planet. We can put between these two quantities our Earth, because it is in like medium size planet, right? Then we are getting a small star, big star. Sun exists between these two quantities. And then we are having huge star. And now we we know that Stephenson 218 is the biggest star ever discovered. Biggest star ever discovered. And you should check this out. This is really very big as compared to our sun. And uh, then we are having small black holes. Yeah, black holes. Big black holes. Supermassive black hole. And well, big black hole consists of this Sagittarius A, which is in the center of our Milky Way galaxy. Sagittarius A, center of our Milky Way galaxy, right? And supermassive black hole consists like M16 or Maser, or some of black holes are there. And we are going to talk about the ultramassive black holes. What happens to my pen sometimes? I don't know. Ultra massive black hole that consists of two major black holes, uh, TON 618, and this is ultramassive black hole. And there is another ultramassive black hole that is more heavier than this beast. This is around 66 billion solar masses. We'll talk about this. And this is Phoenix A. This is a beast. This is about 100 billion. So we'll talk about these two things, right? I love to talk about black holes, right? And then we are having galaxies like our Milky Way, Milky Way, or Andromeda, our neighbor, etc. And then we are having superclusters the combination, like the togetherness of a lot of galaxies, supercluster, and like a lot, like millions of superclusters made up of, and then we are having our observable, and be careful, these things, whatever, like this this is billions and trillions, like just I'm just highlighting those, I'm just highlighting those what do you call names, like those objects, and I would tell you the numbers of them that are combining together to form our universe, and this is in trillions maybe. Okay, trillions or more than that, trillions or more than that. Small star, more than billions, more than billions, more than billions. Well, not more than billions, but it would be like more than many millions, like multi-millions. Small black holes, more than billions. Big black holes, more than billions. Supermassive black holes, more than millions, right? And when we talk about the next day, ultramassive black holes, more than millions. Well, more than millions or something, like these things are very rare, right? So we would keep it in more than a million, something like that. Galaxies, more than billions. Superclusters, more than a million. And then we are having our finally the observable universe, that is so much big. Really, dude, like this is like wow. I need a lot of time to study about the observable universe on Earth, but unfortunately, I'm gonna die soon, as you guys do. So it's not fair. Like I need more time, but don't worry. Whatever I will have, whatever time I will have, I will use it to understand the beastie universe. Okay, so now, far now, we have understood that how big universe is, right? And well, okay, you know what, guys, uh, let me just blow your mind. Okay, I when I was studying about this, I was thinking that I'm gonna just blow my mind is gonna tear up, but be careful, guys, this is going to be brutal, right? Okay, tell me what's 52 factorial? Oh, I hate my this. Okay, what's what's 52 factorial? And if somebody don't know about 52 factorial, let me tell them. What is factorial? Factorial, like let's say n factorial. What is n factorial? Is n times n minus 1 times n minus 2 times n minus 3 times 3 times, no, it's not comma, it's times 2 times 1. Let's put n as 5, 5 factorial. So we are having 5 times 5 minus 1, 4 times 5 minus 2, 3 times 5 minus 3, 2 times 5 minus 4, 1. So we are having 120 as our answer, right? And if you're going to look at 6 factorial, it's 720. So if you're going to look at 52 factorials, okay, so you know what, like this is really going to blow your mind, the value of that number. And why I asked about that specifically number, because this is the number of ways you can shuffle your 52 deck of cards, 52 cards of a deck, sorry, 52 cards of a deck, or you can say like the playing cards. You can, yeah, you can shuffle. And you know what this number is? This is 52 factorial equals 8 point something, or you can say 8 times 10 raised to the 67. Guys, listen. And well, some of you, like most of you, might be thinking that this is not a big number. It's just 10 raised to the power 67. What is this? Like you are writing 8 into 10 into 10 into 10 all the way up to 67. Well, not 67 times, but 65 times, because we have successfully written two times over here, right? So what is the like what is crazy about this, right? Yeah, you are right. Okay, let's come up to our Earth, right? Why did I pick Earth? Because I'm just gonna blow your mind, I promise. We have our Earth right over here, right? Okay. You know what an atom is? Like an atom. It is the smallest quantity in chemical world. Well, I'm not talking about electrons, photons, and neutrons, or more deeply about quarks and something else. But I'm talking about an atom, right? Okay. So atom, like your body has a billion or more than that atoms containing. Well, I'm just holding my pen, and it is containing more than billions or millions, like more than billions times billions atoms. An atom is that small. I think you should check that out, how small an atom is. You know what? Look at your cell. I hope you have studied about cell. Cell is this basic and most fundamental quantity of human body, right? And this is very small. But when you just have a look, like you can't see a cell with your naked eyes. You need a like advanced microscope to just have a look at a cell. But you know what? Cell is far more bigger than an atom. Like an atom is a hundredth of millionth size. Sorry, hundredth of millionth of size of cell. So you can imagine, like if you are going to just have a look at, just imagine this is a cell, right? Human cell. So a, a dot, well, a dot is that bigger, but this, like just have a look at, you can't see it. So this is, well, this is, I think this is even big, but an atom is a lot smaller than that. So I just want to ask about, just imagine how many atoms are there on this earth. I want you to give your answer right now. The question is, how many atoms are there on earth? You know what? Well, just brain, like keep your brain with your head, because it is gonna just leave you right now. Okay, I'm just gonna tell you the answer. It's around 1.3 into 10 raised to the power 50 atoms, right? This much amount of atoms are there on your earth, on our earth. Like just imagine I'm having billion of atoms. 8 billion people are having more than billions of atoms. So like look, 8 uh, if I'm talking about the people, 8 billion times the, what do you call, billion times the billion, and times I don't know what is going on, but this is the population of Earth, and this is the number of atoms in a human body. But we are just talking about the atoms in whole human body existing right now. But there are a lot of non, like, what do you call, non-life, like, um what do you call, like this phone, this pen, they are like, what do you call, um they are not living creatures. So non-living creatures, non-living objects are there a lot. So all of them are just having this little quantity of atoms. And be careful, guys, this is not a little quantity at all. This is a beastie quantity. This is a really beast. And you know what? It is far more less than the number of ways we can shuffle a 52 cards. Really, it's a very harsh fact, and we cannot deny with this. And now I'm damn sure that you are having a curiosity to know how many atoms are there in the universe, and you are just on the way to search it on Google. But before that, let me tell you that it is calculated around 10 raised to the 78 up to 10 raised to the 82 atoms. And now you're going to slap me right away. That Aman, what the hell you're saying? That only this tiny Earth, this tiny Earth is having that much amount of atoms, like 1.3 into 10 raised to the power 50 atoms. And when we talk about the universe, it's just 10 raised to the power 78 or 10 raised to the power 82. What the hell is that? And you would definitely say me that, Aman, you should just get yourself a slap right now. And and I would say that please don't go on Google, because you're going to break your phone. And I'm just taking all this data from Google itself, right? Okay, okay, relax, relax, guys, relax. Okay, so I'm just gonna write this number of atoms in observable universe is around 10 raised to the 72 to 10 raised to the 82. Okay, uh, I think I should just, what do you call? I should just, I don't have any word to describe this fact. Like, you are having, I can't even compare the beastie universe in front of Earth. Like, we are having that that big, even bigger, even bigger. If I have a chance to make it more bigger, I would. So, like, look, this is something like that. This is universe, right? This is universe, observable universe, and there's maybe there is something like that. This is a point, an atom of that scratch, of that, what do you call it, the movement of pen. Well, let me tell you more precisely. And yeah, so look at this. Like, I hope you can see that. Yeah, there is a dot in bluish color, right? And that is describing our Earth. And you're saying that this is containing 1.3 into, well, let me just increase my pen size. Oh my god, dude, don't waste my time. 1.3 into raise 10 raised to the power 50 atoms, right? And this big beast is just containing 10 raised to the power 78 to 10 raised to the power 82 atoms. How is that even possible? Yeah, you are actually right. And I'm respecting your concern about this fact. And now I'm just gonna tell you that how many atoms are there on 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 sun, right? How many atoms in this sun, right? Let's just play with some facts, right? And then we are going to have some sort of relaxation. So we talked about number of atoms, universe, 82, right? And number of atoms, earth, 1.3 into 10 raised to the power 50. Number of atoms on in sun, 1.2 into 10 raised to the power 57. Okay, let's talk about the number of atoms. Number of atoms in the solar system, like in our solar system. Number of atoms in our solar system, right, guys? Just be prepared for that. Number of atoms, solar system. This facts, like, I'm damn sure the one who is gonna listen this fact more um actively is gonna just destroy it, blast it. Yeah, it's well, I'm just checking it on Google because I don't know about that. Our solar system, right? Number of atoms on in sun, in solar system, right? Well, it's just telling me this thing is equal to this thing. I don't know why. Um, well, the Google is telling that the number of atoms of sun is equal to the number of atoms of solar system. Maybe because the solar system is slightly looking like the sun itself. That's why. Um, because if you compare these two quantities, this thing is nothing in front of this thing, right? Because the difference is 10 to the power 7th. That's a huge number. So we would proceed further, and the number of atoms in the galaxy, like in the Milky Way galaxy, and yeah, the Google is telling that the number of atoms in Milky Way is 2.4 into 10 raised to the power 67 atoms. Okay, you know what, guys? When you just add up these two quantities, you would have 10 raised to the power 57. And when you just add up these two quantities, like, look, when you just add up Milky Way, right? And when you just add all the masses inside the Milky Way, like the sun, the solar system, and the other infinite, not infinite, but billions of solar systems lies inside our Milky Way, you would get to have a number of 10 raised to the power 67 only. Like, you would not gonna, I don't think so. You're gonna just cross this value. So yeah, and when you just have just adding all the galaxies inside this universe, you're going to have this value reaches up to 78 to 82. Well, this is a ridiculously big number, right, guys? And I don't have any words to say. We are just writing this value easily, but like, I cannot just imagine how big this number is. I think I should just cut off this topic right now because I'm just gonna blow my head before you guys. Guys, just wait. I'll be just right back and well, I would have some 5 minutes break, but for you it's just a second, right? Wait, guys. Yeah, guys, I'm back. Okay. Um, Now what after all these stuffs, like this is a really, really bad thing that uh yeah, I can say that you must have headaches till now after just hearing that much amount of data, and that's really ridiculous. But it's all right. Let's just have some fun with physics and mathematics, right? Okay. Anyways, let's move on to our another topic that we are going to deal with is how the solar system works. I'm just going to write it down. Well, most of you would know, like you, most of you have an idea about how our Earth is moving around the sun. But why? Okay, okay, let's have this is our sun, our beastie sun. Okay, let me tell you a fact again, a rain of facts, and this fact is really, really good. Like I need you to just listen it carefully. Uh, the what do you call it? Mass of sun is equal to 1.3 million times the mass of Earth. Like more precisely, if you're going to talk about it, it's something like that. One sun is containing 1.3 million Earths. So yeah, this is really uh, bad. Not bad, but yeah, it's a mind-blowing fact. Okay, let's come up to our topic. And we are having some sort of like orbits around the sun. I'm not a drawing perfectionist, but it's all right. Yeah, we will talk about till Earth itself, right? This is Earth, this is Venus, and this is Mercury, right? So every, like we have Jupiter, like Mars, Jupiter, Saturn, Uranus, Neptune. It's all the way up to Neptune, but and there's a Pluto, but it's not considered our part, like the solar part of the solar system, our solar system. It's a dwarf planet, right? We don't need to talk about those things, but we are going to talk about how the solar system works, right? So we know that this little thing is just orbiting the sun. Why? Because it's like the gravitational, the gravity is pulling this planet towards it. But like when you just think of like why, if this gravity, like we are going to have two cases right over here. First one is, I think I should just cover it up. Fixed orbit, and another one is spiral orbit. We'll come up to spiral orbit, but before that, we will talk about the fixed orbit. So Earth is just orbiting the sun in a fixed orbit. That is this. This is the fixed orbit, right? Okay, right, done. So let's just play with some physics. We have a body over here, and this is the path. This is gravity is pulling it towards itself, and another force is just acting outside this to maintain, to balance off these two forces, like this gravitational force, and hence this planet is just revolving, this orbiting this beast. and this is gravity, and this is centripetal force. So we have F gravity equal to F centripetal, and what is gravity is just G m1 m2 over r squared. And what is the F centripetal? It's just m v squared over r. And when you just cancel all that stuffs, then you're having the mass equals the mass of the orbiting body, that is the earth, is equal to what do you call it? um yeah, r v squared over g, right? R g squared over r v squared over g, right? Okay, so we can calculate like if you're having the velocity of the earth orbiting the sun, and if you're having the radius that is around 1.5 billion kilometers, and you need to just check it off like all the data, and then you can get the mass of the orbiting body, that is the earth. But look, at first, at the starting of this topic, I said that gravity is just pulling towards itself. The earth is being pulled by gravity towards sun because of its immense mass. So would it be following a spiral path to get into, like, look what I'm talking about. You know what, guys, I don't have such, like, I need some sort of practicals to make you explain all the things clearly. But I'm really trying to explain you all things clearly because physics is all about practicals. If we are talking about theory, it's just nothing, because if you are just getting practiced every day about a real experiments, then you will get to know a lot of things. You're going to have a lot of experience after experiments. Even though, well, I'll just make sure that you don't get any kind of confusion in it. Okay, so this is the sun, and there is a path of our Earth, right? So I'm not talking about this. Let me change the color, right? We are talking. Let's use white color. I'm not talking about this F centripetal. Let's just forget this. So gravity is just pulling it towards itself. So it cannot be falling into gravity. Like, it's not possible, and we will talk about it later, because it's like there would be a question why the sun is not just getting into, like, just getting dipped, or just getting collapsed with the sun directly. Instead, it is just revolving around it. So it's a great question, and then you would get an answer that F centripetal is working to just what do you call, um, mm, uh, rectify that gravity, to cancel that gravity force, right? But it's not the correct answer. I think you are just applying it to explain. Like, I don't know, like, gravity is natural and it's compulsory to be done by sun, but it's not like you are just, like, you're just forcing people to understand that why. Like, look, guys, I can't explain you everything perfectly, because when you just sit in front of me, I would explain you everything more clearly. But it's all right. I hope you have understand why this F centripetal is being, like, why this formula is derived. This is a forceful formula, like, right? Like, why? Why I need to just apply F centripetal to balance of things? But why I need to balance of things? Isn't there a perfect explanation that, yeah, gravity is working, but something else rather than F centripetal, something else is working to balance it off. Uh, well, it's there's some great questions, and if you're going to ask this to Google, you just going to have, yeah, it is F centripetal, and it is that, it is this. I just don't need all that stuff. And when you just talk to a physicist or mathematician, like more specifically astrophysicist, then you would get to have a lot of Good questions, a good answer, good results. Let's come up to our point, right? So yeah, it should be like it's every moment Earth should be just getting closer to Sun. Okay, let's assume that Earth is revolving around the Sun for some reason, but I'm not taking F centripetal as its main reason. For some reason, right? So it should be just following like those like look, this is Sun, so it should be following a spiral path, something like that. Yeah, it's something like that. Just have a look at this. Every moment we are getting closer to Sun, every moment we are going to getting closer to Sun. And one time, like a lot, like after millions of years, we will eventually fall into Sun if we don't have any sort of F centripetal. So yeah, it could be a possibility. And scientists and physicists have discovered have it's not my theory, but a lot of physicists and astrophysicists have thought about this, have an idea about this thing, but it didn't get a lot of support, I think. But yeah, I'm here and I'm thinking of this thing, but I just need to know the real cause of Earth's revolution around the sun, right? Look, guys, let me just tell you on the next page. We're having that m equals rv squared over g, right? Okay, for the time being, I'm assuming that it's correct. But why? Like, I just why you have derived this formula to just to just to know the mass of Earth, to mass of Sun revolving around the Milky Way galaxy, the mass of an object that is revolving with us with some speed at some distance from that object. Why? Well, and I'm not talking about God right here. Don't just get mixed up with. And I'm a real atheist, right? Well, if you I'm sorry if you're feeling like if you're feeling low with that, but it's my personal thing. I'm an atheist. Okay, so yeah, this thing, and this is how our solar system works. And I just want to know that which one of you think of this is more perfect, this is more clear, or this is more realistic looks like, right? Like the fixed path or the spiral path, right? And well, these and what we should talk of. I'm just thinking of some topic that we can continue of, or else we can start right now. But I would just come up with a lot of different topics of astrophysics. I am really interested in it, guys. I think it's around 48 minutes, and I'm not checking my ability to just sit for 3 to 4 hours and just teach you. It's not something like that. I'm not just telling you theory that you need to just sit straight forward 3 to 4 hours to understand each and every concept. But I'm just imagining you, like I'm just making you to imagine how big this is, how small that is, how it is, why it is, and how, but like when will it end? Um, I think we should just cut off right now. I'm just waiting for 50 minutes to be completed. We have 45 seconds left, and now I hope till now you must have understood what we have studied, and if you have any sort of what do you call question, any sort of confusion, you can just ask me in the comment section. I would definitely reply you. But yeah, and if you want a PDF of this session, yeah, I would provide it too. And please support me, guys. And I really love you. And we are just having for 15 seconds. Yeah, wait for 15 minutes, 50 minutes to be completed. And stay tuned, guys. I will bring a lot of astrophysics and mathematics questions. And in mathematics, I will bring integral questions. Thank you so much, guys. Love you so much.